13.3, Dilations and Measurement. Okay, it wants you to use a centimeter ruler to measure these dimensions. So I'm just going to go ahead and give those to you. So this is going to be 2 centimeters. This is about 1.5 centimeters. This is 3 centimeters. And this is 4 centimeters. Okay, the length of AB is 2. The length of A prime B prime is going to be 4. We're going to do 4 divided by 2. Remember that this is the new over the original. Okay, BC is 1.5. B prime C prime is 3. The new over the original. CD is 2. C prime D prime is 4. The new over the original, 4 over 2. Alright, DA is going to be 1.5. D prime A prime is going to be 3. The new over the original is 3 over 1.5. So what is true about the ratios that you calculated? Well, if you divide all of these out, you're going to have 4 divided by 2, you get 2. If you do 3 divided by 1.5, you're going to get 2. So they're all 2. They're all the same. They are all 2. What scale factor was used to dilate the green rectangle? Well, the green rectangle is, you can't tell because yours is black and white, but it was the original to the blue. So the scale factor was 2. How are the side links of the new rectangle related to the side links of the original? Okay, well, they are twice as long. So the new side links are twice as long. Okay, what is the perimeter of the original figure? Okay, well, that's just going to be 2 plus 1.5 plus 2 plus 1.5. So 2 plus 1.5 plus 2 plus 1.5, which is going to get us 7 centimeters. Okay, what is the perimeter of the new figure? So we're going to say 4 plus 3 plus 4 plus 3. We're going to get 14. How is the perimeter of the blue rectangle related to the perimeter of the green rectangle? So remember, blue is the new and green is the original. So the perimeter of the new, the perimeter of the new is twice as long as the original. Okay, what is the area of the original rectangle? So it's going to be 2 times 1.5. So 1.5 times 2 is 3. So 3 centimeters squared. What is the what is the area of the new rectangle? That's going to be 4 times 3, which is 12. How is the area of the new related to the original? So if we do new to original, we get 4. So the new is 4 times the original. Okay. Let's take a look at a generic formula. So the original could be that we're talking about the perimeter. It could be the area, or we could be talking about the volume. So if we go back to the example we just did, the original perimeter was 7. The scale factor was 2. And perimeter we're going to do to a power of 1. So 2 to the power of 1 is 2. 2 times 7 is 14. Okay, now let's say we did the area. We said the area of the original was 3. We have a scale factor of 2, and we're going to do to the squared power. 2 squared is 4. 4 times 3 is 12. Okay. And if we want to do volume, we can't in this particular case because it's just a 2-dimensional figure, but we could do it. All right, let's go to the back side. All right, we have a scale factor of 3. This side length is 1, 2, 3. This side length is 1, 2, 3. So this is a square. And if we did 3 times 3, we'd get 9. So we would have a new figure that is 9 by 9. So if we did 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this would be 9 by 9. Okay, the perimeter. Well, that's just 3 plus 3 plus 3 plus 3, which is 12. If we do perimeter of the dilation, it is 9 plus 9 plus 9 plus 9, which is 36. Okay, if we did the area, it's 3 times 3, which is 9. And if we did area, we would do 9 times 9, which is 81. Okay, now if you remember, we did do that formula that we had, so we could just test it to make sure. So the original was 12. So if we did 12 times 3 to the first power, 3 to the first power is 3. 3 times 12 is 36. That's 36. Okay, if we do area, area of the original is 9. Scale factor of 3. 3 squared is 9. 9 times 9 is 81. And that checks out too. Okay, let's do the next one. This is 1, 2, 3, 4, 5, 6, 7, 8. This is 1, 2, 3, 4. Okay, if we do 1/4 times 8, we can simplify the diagonal and we get 2. If we do 1/4 times 4, we can simplify the diagonal and get 1. So we can have a 1 by 2. Alright, perimeter of the figure. That's 8 plus 4 plus 8 plus 4. So that's going to be 24. Alright, perimeter of the dilation is going to be 2 plus 1 plus 2 plus 1. So we're going to get 6. Area, we have 8 times 4, which is 32. Area is 1 times 2, which is 2. Okay, we can do the power circle just to check out. So we have 24 is the perimeter times the scale factor 1/4 to the first power. 1/4 to the first power is 1/4. 1/4 times 24 is 6. Okay, we can do 24 times 1/4 to the second power. Okay, so we can square that. We get 1/16. Oops, I wrote, sorry. Sorry. We get 16 times 1/16 times 32, and we get 2. Okay, let's take a look at the last one. A group of friends is roping off a soccer field in a backyard. A full-size soccer field is a rectangle with a length of 100 yards and a width of 60 yards. To fit the field in the backyard, the group needs to reduce the size of the field so it has a perimeter of 128. Okay, so what's the perimeter of the original? We have 100 plus 60 plus 100 plus 60. So that's going to get me 320 yards. Okay, so if we want to find the dilation, we can do the new, which is going to be 128 over the original, which is going to be 320. So we have 128 divided by 320. We get 0.4. 4/10. Okay, so now we can do a power circle. We can do the area of the original, 100 times 60. Is 6,000 times the scale factor, and this is going to be squared. So we have 0.4 squared times 6,000, and we're going to get 960 yards squared.